Radian measures and trigonometric ratios. The terminal arm of an angle is in standard position passes through -3, 4. Find the exact value of trigonometric ratios. Okay, so let's try to sketch it first and then solve the problem. So that is our coordinate plane, and the point given to us is at -3, 4. That means 3 units minus x and 4 plus. So somewhere there. What we can do is we can join this point with the origin since the angle is in standard position. There it is. So angle in standard position means that the vertex is at the origin and the initial arm is always along with the x-axis, correct? Now that is our terminal arm. Find the exact value of primary trigonometric ratios. So the angle basically is, if you see, then the principal angle is this angle at this position. Principal angle is always taken counterclockwise from initial to terminal arm. But as far as trigonometric ratios are concerned, so what we do is we drop a perpendicular from here to the horizontal x-axis, right? And then find what are the opposite sides, adjacent sides, and the hypotenuse. The point is -3, and this point here is 4. That means, let's consider this angle alpha. That is the related acute angle. And theta for us is this principal angle. To find trigonometric ratios, what we consider is basically the triangle shown in quadrant 2. This is quadrant 1. This is quadrant 2. Quadrant 3 and 4. Now we are already given the two sides when we know the coordinates, which is -3 and 4. -3 is the x value, so we know this side, and 4 is y value, so we know this side. This is 4 for a point which is -3, 4. So what we should find is also the radius or the hypotenuse of this triangle. Okay, when we say radius, we're trying to say, well, consider it to be a circle and this is a point on the circle. So sometimes we refer to word r. Okay, so you'll see in ratios like sine theta is y over r. Let's find this hypotenuse. We may call it r for the time being, right? So here r is equals to 4 square plus 3 square square root, correct? R is always positive. Since this is a right triangle, and that is how it is right, we dropped a perpendicular from here, right? So that gives us 16 plus 9 square, which is square root of 25, 5. So r is equal to 5 for us. We can write what is the value of x. X is equals to -3 and y is equals to +4. I'm writing -3 and +4 purposely because at times this point could be in different coordinates, and that straight away gives us the sign also. So the question is, find the exact value of primary trigonometric ratio. Three primary ratios are, trigonometric ratios are sine, cosine and tangent. Okay, so we'll find sine of sine of alpha. So sine of alpha will be opposite over hypotenuse, which is 4 over 5. R is equals to 5. We calculated, right? So it is 4 over 5. 4 is also positive and 5 is also positive. Sine is positive, correct? Now cos of alpha is equal to adjacent side, which is -3 here, over 5, correct? And tangent is opposite over adjacent side, which is 4 over 3. So these are the exact values of our primary trigonometric ratios, right? Do they match with our cost rule? Let's try to figure it out. Cost rule says in quadrant 4 we have cosine as positive, in quadrant 1 all are positive, and in quadrant 2 we have sine as positive. Yes, we see sine as positive and the other two are negative. Well, I did make a mistake, minus 3. So I should have written here minus 3. So tan alpha is minus 4 over 3, correct? This is always good to check. And in quadrant 3, tan is positive. So as you can see, it's good to write the coordinate as minus 3 and 4 and use these values. You should always write r, x and y values very clearly so that you can find your trigonometric ratios exactly. Okay, that's kind of important. And even before you start, you should know what are you expecting, at least the sign of all the trigonometric ratios. So when you are in quadrant 2, you should expect sine to get positive values and the other two as negative so that you don't make this kind of mistake. Thank you.